Hello and welcome back to Anton Math. Now in these next three videos we're going to be looking at probabilities of basic standard types of problems that are really applicable in real life. If you haven't watched the first two probability videos, I do recommend that you go back and look at those, but if you have a general idea of probability you should be fine. Now this first video we're going to be talking about choosing marbles problems. And choosing marbles problems have a lot of real life application. Anywhere you're in a situation where you have a set of something and you're looking at the probability of choosing a particular subset. So even if you're looking at election polling, let's say you do election polling randomly in an area with 900 residents where 500 are Republican and 400 are Democrat, you could ask the question, well, what's the probability at least half of the people polled were Democrat? You know, something along those lines, and that all comes from this basic outline of these choosing marbles problems. So we're just going to do a couple of examples. First, there are 12 red marbles and 3 blue marbles in a jar. 3 are selected at random. What is the probability that all are red? So what we're doing in this, we're going to break this down into a uniform environment like we've been talking about. 3 are selected at random. So we need to break this down into the environment where S is all the possible ways of choosing 3 things. So my sample space is going to be all the different sets of 3 marbles that I can choose, and we know that all the different ways to make subsets of 3 marbles from a set of 15 marbles is 15 choose 3. Now I don't need to break this down into all the different choices, I just need to know how many there are, right? I have 15 total marbles. The number of ways that I can choose 3 marbles out of 15 marbles is 15 choose 3, right? So we're going to be using this in corporation with our probability. Now the order of my event E is all the different ways that I can choose 3 marbles, right? This is all of my different sets of 3 marbles. I want to look at just those where all 3 marbles are red. Well, that's just going to be, I have 12 red marbles, so there's 12 choose 3 ways to choose 3 of those marbles. So my probability of E, we're in a uniform environment, right? Each of the sets of 3 marbles are equally likely to be chosen. So this is just going to be the order of E, which is 12 choose 3, over the order of S, which is 15 choose 3. Now we're dividing by a fraction by a fraction once we write this in its form. So I'm going to write the first choice function, 12 factorial over 3 factorial 9 factorial. And I'm dividing by 15 choose 3, so that's the same as multiplying by the reciprocal. So I have this 15 factorial on the bottom, and I have a 3 factorial, 12 factorial on the top. Now these 3 factorials will cancel, and this is going to reduce to, on the top, 12 factorial over 9 factorial gives me 12 times 11 times 10. On the bottom, I have 15 factorial on the bottom, 12 factorial on the top. So that's going to reduce to, on the bottom, 15 times 14 times 13. Right? Everything else from the 15 factorial cancels with this 12 factorial. And that's going to simplify down to 44 over 91. Okay, so a simple warm-up problem, give us an idea of what we're doing. We're going to be using all of our knowledge of the binomial coefficient, or this combination function, in order to do these more complicated probability problems. So let's take another look at a marble problem. So a box contains 4 red, 3 white, and 2 blue balls. 2 balls are chosen at random. What is the probability that they are the same color? So not the probability that they're both red this time, but the probability that they're both the exact same color. Now again, we need our order of our sample space. We have 4 red, 3 white, and 2 blue, so that's going to be a total of 9 marbles. And we're looking at, we want to know how many different pairs can be chosen out of 9 marbles. So that's just 9 choose 2. Let's call E sub r the event that 2 red balls are chosen. So the event space, E sub r, is going to be 4 choose 2. I have 4 red balls, so 4 choose 2 gives me all the possible number of ways that I can choose 2 red balls. And 4 choose 2 is 6. Let's have E sub w be my sample event, or my event space for choosing 2 white balls. That's going to be 3 choose 2, which is 3. And let's let E sub b be the event space where I choose 2 blue balls. I only have 2 of them, so that's 2 choose 2, which is 1. There's only one way to choose 2 blue balls if I only have 2 blue balls. So now I'm looking at the probability that I choose 2 red balls, or I choose 2 white balls, or I choose 2 blue balls. Now choosing 2 red balls, 2 white balls, or 2 blue balls, these are disjoint events, right? These don't share any sample points. This is all the sample points of 2 blue, 2 white, 2 red. Nothing's shared. I can't choose 2 red balls and 2 white balls. So this is just the order of ER plus the order of EW plus the order of EB over the order of S. Or you could think of this as you could find the probability of each of these events individually and then add that all together. That's fine too. That's exactly what we're doing right here, isn't it? So writing this in, I have ER was 6, EW was 3, EB was 1, and my order of S is 9, choose 2. And I'll let you work out this calculation, but over here I get a total of 10 on the top. My 9, choose 2 should be 36. This is going to give me 5 over 18. So the probability that the 2 balls I choose are the same color, no matter what that color is 5 out of 18. Alright, so this is the choosing the marble type of problem. In the next video, we're going to be talking about card problems. Now, card problems are probably one of my favorite types of problems. So I'm going to do a nice big example that we can work on over there, and we'll see you there.